So in this lesson, what we'll get introduced to is what a mixture is, and then we'll look at what a solution is, because a solution is a good example of a mixture. And the experience and outcome that this relates to is I can differentiate between pure substances and mixtures in common use and can select appropriate ways of separating them. So separating mixtures will be what we look at later on. We're just focusing on what a pure substance is and what a mixture is today. So to start off, you'll have done this before, element or compound, but it's just for revision. What I'd like you to do is identify any of these boxes that are elements. So some of them will be elements, some of them will be compounds, and maybe some of them will not be either of them. So had some time to work out which ones are elements. The ones that are elements are A, B, and D. The reason why these ones are elements is because if you look inside the box at each one only contains one type of atom. So A only contains those purple atoms, B only contains those blue atoms, and D only contains those green atoms. Now for compounds, the ones that are compounds are C and F. And that's because we have got more than one type of atom in each of those boxes, and they are chemically joined together. So in C, we can see that the red atom is chemically joined to the blue atom. And in F, we can see that we have the orange atom chemically joined to the green atoms. Now, E is neither an element nor is it a compound. And that's because we have got something that looks like a compound, the dark blue and the light blue. Those are chemically joined together and they're different types of atom. So that might be a compound. But then we've also got these pink atoms. And those pink atoms are not chemically joined to anything. So E isn't an element and it's also not a compound. So what is it? Yes, what was substance E? Well, A, B, and D were all elements, as we said, because they contained only one type of atom. C and F were compounds because they contained more than one type of atom chemically joined together. And what we would describe all of those as being pure. They only contained one type of chemical present. But E had a combination of things. We had one thing, which is the pink atoms. They're one substance. And then the triangles made of two light blue and one dark blue atoms, that's another substance. So it's not pure. E contains two types of chemicals or two types of substance. It is not pure. And any chemical that is not pure, or how we would describe it as impure, is called a mixture. So E represents a mixture. Mixtures are nothing new. Lots of things are mixtures. Air is a mixture of nitrogen, oxygen, carbon dioxide, and water vapor. Seawater is mostly a mixture of water and salt. Fizzy drinks are a mixture of water, sugar, caffeine, and acids. And even bottled water that you might think is very pure is actually a mixture. And if you look at the back of a bottle of water, you can see it's got a list of things inside it: sodium, calcium, magnesium, chloride, sulfate, nitrate, which proves that it's not even a pure chemical. It's a mixture. Now, mixtures can be of different things. So if you look at the box on the left, we can see that inside there we've got two things. We've got the green atoms and then we have got the orange atoms. If we just look at the green atoms, we can tell there's only one type of atom, they're all the same thing, and that would, if we just looked at the green ones, that would represent an element. Now, if we just look at the orange atoms, ignoring the green ones, we can see that, well, those orange things are only made up of one type of atom, so that would be an element as well. And so that first box is a mixture of the element made out of green atoms and the element made out of orange atoms. Now, the second picture, what we have is two things again. If we ignore the triangular ones, the blue ones, and just look at the yellow atoms inside it, if we just looked at those, we would describe that as an element because it only contains one type of atom. Now, if we remove the yellow things and just look at the other ones, well, you can see that they're triangles made up of two light blue atoms and one dark blue atom, but they're overlapping with one another, which means that they're chemically joined. So that represents a compound. So what the middle box is a mixture of the yellow element and the light blue, dark blue compound. And finally, what we have on that last slide, we can see that we've got two things again. One thing that's made up of a red and an orange atom, and one thing that's made up of a green and a purple atom. If we look at just the ones that are red and orange, ignoring the other ones, we would describe that as a compound because it's two different types of atoms overlapped, which means that they are chemically joined. If we look now at just the purple and green ones in that last box, ignoring the orange and red ones, they are also a compound because we've got two types of atom chemically joined together. So a mixture in that case of a compound and another compound. And so mixtures can be of elements, they can be mixtures of elements and compounds, or they can be mixtures of compounds. So now what we're going to look at is one of the most common types of mixture, and that is a solution. And a solution is made by dissolving usually a solid in a liquid. And examples of this are if you put salt into water, the salt dissolves in the water to make a salt solution. And that would make salty water. An everyday example of this would be putting sugar into coffee. When you put sugar into coffee, it dissolves. You can no longer see the sugar, but it's part of a solution. Now, a solution is produced when a substance dissolves in another substance. The substance that is dissolved is called the solute, and the substance it dissolves in is called the solvent. Now there's a rhyming way to remember this, because whenever you're making a solution, you put a solid in a liquid, and the word solute is what was put. Solute, put. Solute is the thing that was put into the liquid. The solvent is where it went. So the solute is the chemical that was put inside another chemical. The solvent was where that solute went, if that helps at all. And we can put this together in a simple thing that a solute, which is the solid thing which can dissolve, when it's added to a solvent equals a solution. You notice in this case I put an equal sign and not an arrow because we're not doing a chemical reaction in this case. It's not a transformation. We are making something that still contains the solute and the solvent. Now, there are a few words we need to understand. And the first one is any substance that dissolves is described as being soluble. So sugar is soluble in water. A substance that cannot dissolve is insoluble. So a good example of something that's not soluble, that's insoluble, is your hair. Hair is insoluble. If hair was soluble, anytime you tried to wash it, it would just disappear down the plug hole with the water. Now, every substance that is soluble is only soluble to a particular level. Once you can no longer dissolve any more of a substance in a solution, that solution is saturated. It's filled up with solute. So a way you can try this at home and prove and make a saturated solution is either if you've got salt or sugar, and if you take a small amount of water and add in a little bit of salt or sugar at a time and stir it, you'll see that it fully dissolves. If you keep adding a little bit more, dissolving and stirring it, you eventually get to a point where it won't dissolve and you'll end up with solid salt or sugar left at the bottom. At that point, that's what we call a saturated solution. So from this slide, we know that if a substance can dissolve, it is soluble. If it cannot dissolve, it is insoluble. And a soluble compound that has completely filled up a solution until it cannot dissolve any longer, we call that a saturated solution. Now, water is not the only solvent that exists in the world, and there are some compounds, some chemicals, that can dissolve in water, but not in other solvents. And sometimes there are solvents that can help dissolve things that water cannot. For example, nail polish remover is a different solvent than water, and it allows you to remove nail polish, whereas water doesn't get rid of nail polish because it's not soluble in water. And as I said, water is not the only solvent. Acetone is the solvent inside nail polish and nail polish remover. Turpentine is a solvent that is used for extracting perfumes from plants, and it's also used to dissolve oil paints. And also, if you've heard of dry cleaning, so dry cleaning is where your clothes essentially get washed using chemicals that are not water. And it's dry because those chemicals evaporate quickly. So that was a summary of mixtures and an introduction to solutions. There have been no questions during this one, so look forward to some questions in the next video, and I'll see you next time.